So what you see behind me is our SmartPod platform. The SmartPod platform is designed for larger edge type of deployments and data center. It's an open tank system, which essentially means it's a bath of liquid, and we'll be looking at this in detail now. We'll open the system and run through it. But these systems in production, together with the secondary cooling that's required, they operate at a PUE of 1.03. So a massive reduction and really looking at getting that PUE right down to 1, which is the journey that we're on. And they allow us to increase substantially the density per square meter, because the smaller system can host up to 50 kilowatts of IT load. The bigger system, 100 plus. So we have configurations and deployments today that are in the range of the 100 kilowatts per tank. So without further ado, let's have a look. And Edgar, if you can help me open the unit, and I'll showcase you what's in it and how it works. So what you'll see here is obviously it's a tank full of fluid. The way that the fluid is managed is by injecting the cold fluid at the bottom of the tank evenly along the tank. It flows gently through the IT hardware, and it's collected then again by the cooling distribution unit, which is the brains of the system. And the cooling distribution unit is designed to pump all that fluid through a heat exchanger which is inside of it and transfer all the heat to the facility water loop. The cooling distribution unit has certain redundancy built into it. It has 2 pumps. It is fully submerged, and it has a server form factor to be managed like a server and to be even extracted and replaced like a server, and we'll see very briefly how that is done. But what you can also see in this tank is that we have 2 types of hardware configurations: 19-inch equipment on this side of the tank, and 21-inch OCP equipment on the other side. Today have multiple OEMs and ODMs in the case of OCP, which are supporting, embracing, and providing systems for immersion, and truly looking at achieving these higher density systems that allow us to push those rack densities up and deploy these HPC environments in immersion.
So, Daniel, what can you tell us about the fluid itself?
We've designed this fluid specifically for this application. It's developed by Submer for immersion cooling, and so it has a very long lifespan, 15 years. It has the capability of capturing and transporting the heat super efficiently. It's non-toxic, it's biodegradable, it's classified as food grade, and another interesting property of the fluid, apart that obviously it acts as a natural barrier to dust and particles that could potentially or that cause a lot of the hardware failures in data centers. Obviously this environment has no moving parts. It's completely silent because there are no moving parts, and obviously the hardware failure rate's directly connected to that. But another nice property of this liquid is it's non-flammable. And it makes things much easier from a data center security perspective. So very briefly again about the CDU, the brains of the machine. In this unit we just have 1, which means we have 50 kilowatts of dissipation capability. We do have the possibility of deploying 2 CDUs in this system, which means we can either provide more redundancy and resiliency by bringing separate water feeds to each CDU, or we can completely add up the dissipation capability of each of those CDUs as well.
And that means that we can go up to a tier 4 category.
Yeah, tier 3,
deployment.
tier 4, and actually we're very close. We're working with the Uptime Institute to kind of get an official certification from them regarding that, because a lot of our customers are asking us, hey, I want to make sure that these systems, this is a cooling system, I want to make sure it's not going to disrupt my tier certification with the Uptime Institute.
Absolutely. Now we've talked about the inside of the tank. Let's go to the dry zone, to the outside of the tank. What can we see there?
So the dry zone, and Edgar, if you can help me remove the lid, please. The dry zone is designed to host the components that we don't want to submerge in the tank. Thank you. The dry zone will typically host power distribution units. So these are the typical APC power distribution units that you would have at the back of a rack. We deploy them outside the tank because they don't practically generate any heat. But in this area, we'll also have different accessories for cable management. We'll deploy switches, networking gear if needed, but we'll also deploy networking gear inside the tank because it's fully compatible. Copper and fiber optics are fully compatible in
that's a matter of choice.
It's a matter of choice. We have customers that they want the higher density switches to be placed outside and the top of the rack lower density switches inside. It really depends. But another thing that we see in the dry zone is the connections to the CDU. Now the connections to the CDU occur above the fluid level, so this tank does not have a single hole in it. And we actually have a couple of options when it comes to tanks with a single hull and a dual hull environment, meaning that we have full secondary containment of the fluid built into the tank. But if you have to replace a CDU for a preventive or an emergency maintenance operation, it's as easy as disconnecting the quick disconnects that are so these hoses will will connect with the facility water. They're flexible hoses that typically would connect to the major distributor pipes that are supplying the water feed to the immersion tanks or other type of systems in the data center that require water. And again, this water loop runs at very high temperatures, typically in the range of 40, 45 degrees centigrade, which means, again, we can work with these systems anywhere on the globe with dry cooling technology. Again, connecting with that zero water consumption. So Edgar, if you can help me disconnect one of the hoses so that we can show these hoses are pressurized. They supply water to the system in real time, and so that's how quick it is to disconnect one of these hoses. Obviously, we'd take both of them out, and we would be able to extract a CDU in less than 5 minutes. That's the whole system is designed for that. And of course, the CDU is fully submerged in the liquid. It's cooled by the liquid itself. So all the electronics that are in a CDU are leveraging immersion cooling technology themselves. That's how much we trust our liquid to that we even run our CDUs in it.
So Daniel, now whenever we disconnect the water loop, the temperature in the tank will rise.
Yep.
How long will it take before the servers start switching down?
Yeah, and we mentioned like replacing a CDU is a 5-minute job. So there's a term that we call thermal inertia, which defines the amount of time and the increase of temperature over time. Systems will typically shut down when the set point reaches around 90-95 degrees centigrade. You'll start seeing servers shut down. I guess that's a natural security measure to an issue like a full system failure. But you typically have, with a fully loaded system, you have 30 minutes before that occurs. So you have more than enough time to replace a CDU without shutting down the system. And of course, if you have an environment where you have 2 CDUs, then you're looking at, for sure, no risk of downtime at any moment in time.
Absolutely. Yeah. Now, we've talked about the liquid, we talked about the dry zone. What can you tell us about the telemetry of?
Yeah, so these systems, they have more than 25 sensors in them. And those sensors monitor everything from temperature, flow rates, the heat that's being exchanged, fluid quality, etc. And all that telemetry is accessible through an open API. And at the same time, we obviously represent that on a visual interface to allow customers to, in this case, see the operation of a single unit. So the set point temperature, the mechanical PUE of the system, the temperature at which the fluid is at the very top of the system, the heat dissipation capabilities, and then you can obviously dig into more detailed information of how the pumps are performing. The two pumps that, as I mentioned, switch over every day to guarantee that the operation is resilient and that the pumps are operating correctly. Interestingly, also the amount of power consumption for the CDU, that's where we get our mechanical PUE, that super exciting mechanical PUE. We've just had
The pump started working.
the pump started working. So if we can go into the top camera, what we'll see is how the fluid is being captured along the side channels here, and is running through the CDU to transfer that heat to the heat exchanger and to the water loop, which is definitely not happening now because we've disconnected one of the hoses. All that telemetry is accessible from a SmartPod level, API as I mentioned as well, and also the whole, if you have a set of SmartPods, a whole SmartPod farm, we provide a web interface that also allows you to drill down into the farm, see the efficiency of the farm, configure certain values, etc.